Now what's that? Looks like a number line, doesn't it?
It looks like a number line.
Yeah.
Is it a number line? I think it's a number line.
I turned the camera on.
Camera's on.
Camera's on. Now they can't see this part of the screen.
Hello,
right
boys
there.
and girls.
Hey, this is Chris Murray.
And Tom Duggan.
And we're just here to teach you about vector velocity and physics quantities.
Vector velocity and physics quantities. It's important to know which way you're going, right?
I think so. I'm going to turn off the camera here because
yeah, you don't want to.
I didn't comb my hair.
Yeah. So anyway, what you got is, if you're looking at this number line, everything to the right is going to be positive, and everything to the left is going to be negative. And what it says at the bottom of the screen, in our world, there's two directions, positive and negative. And that not only goes for like your position or your displacement, which we call x, but it also goes for your velocity as well. Now, hopefully this is not the first number line that you guys have ever seen. I'm guessing that you guys probably have seen some, like maybe in elementary school, I'm hoping.
Yeah, I'm thinking so.
Hoping. And, if it's ever hard for you to remember, there are some people that say things that lean to the right are positive, and some people that things leans to the left is negative. And those people are usually kind of conservative people. The right is positive people. But, we'll see. At least that's the way it works in physics too. So let's say that you started at a position of -4 meters, but you went in the positive direction 5 meters. See, Mr. Murray is so smart. Look, he already wrote +1, because +5 plus -4, your change in position is going to be 5 meters, so that if you start at -4, you're going to end at +1.
There you go. So that's a displacement of +5, and that just gives you the direction. And that's a little bit like football.
It's a lot like football.
They'll say that the play gained 5 yards. You could also lose, right? So displacement the other way would be negative, right? So when you look at these things, the negative there doesn't mean that you owe somebody 6 meters. It means that it's just a 6 meter change in position to the left. Okay, that just means to the left.
Precisely. So
and
like,
this is to the
if
right.
you started at -4 meters, that's like saying that you're second down and 14.
Uh-oh.
Hey, there's a telephone call.
Yeah.
I don't know.
I think we're going to ignore that telephone.
I guess we're going to ignore the telephone
It's going to
call.
just go to the answering machine.
You know what? We're going to ask you guys, whoever was the video lead, what happened that was a weird event during this video.
Yeah. The code word is telephone.
The secret code word
It's telephone.
is telephone, boys and girls. So anyway, you're saying that on the first one you had a gain of 5. So if that was true, then you'd still have some left to go. But then guess what? The next one, where it was to the left, that's like the quarterback got sacked, right?
Uh-huh.
He was running backwards and couldn't go any forwards, couldn't get rid of the ball, and got sacked because he went to the left.
And then there's velocities can also be positive, right? So if I've got a velocity of +1 meter per second, it means I'm moving to the right. If I have a velocity of, I don't know, let's just make up another number, -2 meters per second, right? That's a faster velocity. It's also to the left. Okay, so this is a bit like the difference between drive and reverse. Drive could be positive velocity if you're facing in the positive direction, and reverse would be negative velocity. Okay, and I've got a funny story I'll tell you about confusing that, which I occasionally do. But
it happens there we have it. From time to time.
Okay, now I'm just going to hit erase here and erase all those nice pretty things there. Our velocity is change in x over t. So therefore, our displacement is really this delta x, right? Is velocity times time. So for all these problems, when we talk about the number line, notice there's an original position that we start at. This might be our initial position, right? And this might be our final position, right? Our final position for this particular displacement right there, right? This is the formula that we're going to use for these little example problems. Is that the final position is the initial position plus how much we change in position, which is going to be this guy here, right? So velocity times time.
That's going to be awesome. Now, don't let the little x with the little f and the x with the little I. Those are called subscripts. Okay, and that means final position and initial position. So when you're telling the other two people in your group about that, tell them, it looks kind of scary maybe, but it's not. And then v is still velocity and t is still time. It's just that those are subscripts, and if you were saying that out loud, you'd say it x sub f and x sub I. Or you could just say final position and initial position. That's even easier.
And then if you look at this displacement, this particular thing here, the initial position is probably +3 and the final position is -3, right?
That's correct.
If you go from +3 to -3, that's a total change of -6.
Awesome.
So what's going to happen now is we're going to stop this video and we're just going to bust out some examples. I don't think you probably understand it yet, so I think you should probably work out at least a couple of the next examples. Okay?
Yeah, when you get to the examples.
And these will be the whiteboards in class.
Exactly.